Welcome to the third breakout session here at our main stage. And now time for that session, talking about AWS architecture design, not a one-time event. Please welcome from Rackspace, Senior Solution Architect, Jerry Hargrove.
Thanks. Happy to be here. I want to mention that there's a slight change to the slide deck. We're actually going to talk about the offering itself first. So I'm going to talk for maybe about 10 minutes just about the fanatical support for AWS offering that we have, talk about it a little bit, and then I'm going to slide into the actual sort of more technical portion of the talk where I'm going to talk about architecture for the last probably 30 minutes or so. So let's go ahead and get started. As I mentioned, as was introduced, I'm a solutions architect, an AWS specifically solutions architect at Rackspace, and I work with customers like yourself, helping them to architect their solutions for the cloud. And I want to talk a little bit today about our new support or our new offering. But first I want to provide a little bit of context. I won't go into great detail about this because many of you are already customers and you know about Rackspace. But I wanted to talk just a little bit about where we are and how we got here. Rackspace has a vision, and that vision is to be recognized as one of the world's greatest service companies. And over the last 15 years, we've seen a progression in that direction, starting with support for Microsoft, moving on to VMware, collaborating with NASA in the creation and founding of OpenStack, and then last year our support for Microsoft Azure, and most recently, as of October 2015, just last year, we announced our support for Amazon Web Services, the leading public web provider, and the form of fanatical support for that. When you think about Rackspace, this is what we want you to think about, that our goal is to fit you with the best available technology to match your needs. It's all focused on customer outcome. Our vision has been the hallmark of this company for the last 15 years, and it's how we differentiate ourselves in this space. Our goal is to help you take advantage of the power of the cloud. In this case, I'm talking about AWS, but it can be any public cloud, really, without the challenge and expense of actually managing it yourself. How many of you here today are Amazon Web Services customers right now? Okay, good. So we've actually got a good crowd. How many of you are not, but are thinking about trying out AWS? All right, so this eye chart is Amazon's public portfolio of services. It's actually grown quite a bit. I've been involved with AWS for about the last 7 years, and when AWS first launched, this was probably just a fraction. Their services were just a fraction of this chart, maybe just half of one of those columns. They have a very robust platform that's growing and changing all of the time. They're constantly announcing new features and services. It's not uncommon to see 5 or 10 new features or service announced each week. And keeping up with that keeping up with all of those services and features can be a full-time task in and of itself. Thus, that's really my role. That's what I do for a living. And so it's very important that we have somebody around who can do that. When we started talking with customers about what they were looking for in their journey to the cloud, in their journey to AWS, we found that the use cases where they wanted us to help out really fell into these 4 major buckets, and I'll talk about each one of them briefly. About migration, architecture, security, and operations. When we talked to customers about what they wanted around migration, they were asking questions like, how do I move my applications to AWS? How do I take my existing infrastructure and move it over to AWS? How do I take my databases that I have on-prem or in another provider, how do I migrate that over to AWS? And this is part of what we provide in our new service offering, is that guidance and best practices around how to move your applications over. Also, and really what I do on a day-by-day basis is architectural guidance. So I've got my application over there, or I'm thinking about building it on AWS. How do I take advantage of all of the services? How do I how do I take all of those and map those to my application? How do I make sure that I'm using best practices associated with AWS and operating in the cloud in general? Again, that's part of the role that I play in interacting with customers as I go out and I work with customers and actually talk to them about how to architect for scalability, how to architect for availability, how to be resilient. And that's what the latter half of this talk is really going to be about, is that topic there. We also talk to customers about security. So how do you take your application where you're interested in some type of compliance or governance? How do you map AWS services and best practices to your application? If you have a HIPAA compliant application, for example, a PCI compliant application, what services and best practices can be applied there? And then finally, the day-to-day operation of your environment. How do you manage your AWS infrastructure? What do you do with it? Our job is to come in and work with you to figure out, number one, where you're at today, where you want to go, and help you map out a strategy for moving that direction, whether it be on the SysOps side or the DevOps side or somewhere on that continuum in between. Our goal is to help you move in that direction. If you look at this chart, so on the right-hand side, you see that AWS, this is the Gartner Magic Quadrant chart. On the right-hand side, Gartner has recognized AWS as the leader in the infrastructure as a service category. On the left-hand side, you see that Rackspace is recognized as the leader in the managed cloud category. Now, when you take those two and you combine them together, it produces a very powerful, very great experience for customers. We're the respective leaders in those areas, and when you tie us together, it leads to a very good, excellent customer outcome. Part of that is because we're staffed by many rackers, you've probably heard that term today, with accreditations associated with AWS, both technical and business accreditations. Over 200 of us at Rackspace are certified AWS, either solutions architects or DevOps engineers or developers or some combination of both of those. And I think more than 16 of us now have professional certifications in that space, which is a feat in and of itself. We're at the top of the managed services ecosystem in that respect with the number of certified AWS professionals we have on staff, and we're available globally on a 24/7 basis. When we look at the offering itself, what we provide, we actually provide two service levels, both of them intended to get our customers to the same endpoint, and that is into a managed AWS service environment. But they're targeted at two slightly different customers. On the left-hand side, you'll see our Navigator offering. This is geared more towards a customer who maybe has some AWS experience, who wants to have a hand in the management of their AWS environment, but recognizes that they might need some guidance. They might want to call in an architect. They might want to get some assistance on operation. They want to have available to them some of the tools and automation that we've built around AWS, but they really want to take on some of the workload themselves. So that's the Navigator offering. On the right-hand side, we have the Aviator offering. This is geared more towards someone who wants to have us take over the management and administration of that environment. So think about a customer who might not have as much AWS expertise in-house, for example, and they want to use their valuable resources, their engineers, their designers, their architects on their core business, and they want someone else to come in and help administer their AWS infrastructure. You get all of the same benefits as a Navigator, all of the tooling, all of the architectural guidance, the human expertise, as well as other offerings that we've built on top, or other services that we've built on top of AWS. Logbook, for example, which provides aggregation of logs across multiple environments in AWS. Watchman, which is the integration of our environment with CloudWatch and CloudWatch metrics, so that the engineers who are watching your account can be they can monitor and be alerted when something is going on in your account. Compass, which provides AWS's Trusted Advisor service as a base layer, as well as other Rackspace opinions on top of that to give you a dashboard of how your environment looks, whether it's following best practices or not. And also Passport, which provides a very dynamic, secure, trusted way of accessing your environment through temporary bastion hosts. So we've built these best practices into the offering already. Again, we've formalized this relationship with Amazon. We partnered closely with them prior to launch to obtain our managed service provider designation. Just recently, we obtained our AWS DevOps Competency. We're an advanced consulting partner and an AWS reseller. And when you think about the number of us within Rackspace who are actually certified, there's about 10% of us within the company itself have some accreditation or certification with AWS, which in and of itself is a unique number. It provides a very significant stance and a commitment by Rackspace to this offering. Also, 100% of the engineers, architects that you work with in the fanatical support for AWS offering are AWS certified. And we've gotten some great feedback from not only from Amazon as a partner, but also from customers that we've worked with. And as you progress in your journey towards AWS, I think, and you explore your options and look at the choices that are available to you, I think you'll find the same. If you want more information about this offering, you go to rackspace.com/AWS. There's a lot of information there. I'll be available after the next talk. We also have several staff out at a booth, at a Fanatical Support for AWS booth. So if you have any more questions, feel free to ask. So that was the very high level, very quick overview of our offering. I'm going to switch gears now, and we missed the first page. So I'm going to switch gears now. I'm going to dive a little bit deeper, and I can't guarantee I won't go really deep, but I'll try to keep it at a fairly decent level. So one of the things I do is I go out and I talk to customers. Sorry, the transition is causing me some issues here. One of the things I do as a solutions architect is I go out and talk to AWS customers, and I work with them as part of this program. I've been doing this even prior to Rackspace. I worked at AWS as a solutions architect there. I was an independent consultant as a solutions architect, and I've worked with many, many AWS customers and worked with them in migrating and moving their applications to the cloud. And what I want to share with you today as part of this presentation is just part of that journey, how an architecture might evolve as you move it to the cloud, whether it be just a very small, simple web application that a startup might be using, or an individual component within a larger portfolio of applications may be used at an enterprise level. And I want to share with you some of the best practices and patterns we've seen at Rackspace when customers have had successful architectures. And I want to cover a couple of separate, different points, key attributes. So the first attribute I want to talk about is scalable architectures. Scaling in the cloud. So one of the key attributes of a successful architecture in the cloud is it becomes scalable. And ideally, this is ideally what we're shooting for. Architectures that survive and thrive in the cloud are scalable. That means that they can shrink and grow dynamically. They're very elastic, and they shrink and grow to meet the demand of your customer. So as your workload in the cloud grows and your customer demand grows, your infrastructure grows with it. And so it has to be able to do that fairly dynamically. I don't know if you're not in AWS, or you remember maybe in the past how this usually happened was you knew that you were going to need additional capacity sometime in the future, and so you put in a request for that, you put in a procurement request for that, maybe you went through several levels of approval for that, you got funding, you got finance. Several months down the road, you may then receive the systems, be able to integrate them into your stack. So you had to start thinking about these things maybe months, weeks or months in advance. When we're talking about scalability and elasticity in the cloud, we're not talking about weeks, or we're not talking about days. We're actually talking about minutes. We want to be able to expand and contract your environment on the scale of minutes. And while we're doing that, we want the experience of your customer to remain fairly static. So if you have one customer that's using your system, their experience should be the same as 1 million customers on your system. We want your system to be able to accommodate that growth, and your users for it to be transparent to your users. We also at the same time want to make sure that this growth is, we're being fairly frugal, that we're being economical about it, that we're provisioning resources that meet our demand and not much more. I like to step back and sort of look at this very simple application here as sort of a baseline. This is a very common case when we're working with small customers or individual applications where evolution, in terms of evolution, this is the beginning. Very often you have an engineer who might be working in an office, they put their application, they put the database, they put everything on one box. It's an app on a box. This is our evolutionary starting point. Everything exists here. This is the monolith, and very often where we start from. Not just for startups, too. When I'm working with large companies, enterprises, too, this is very often the case. They have many services. Some of them end up being like this, a big, huge single point of failure. We'll talk about some of these a little bit later on. How do we actually scale our services in the cloud? Some of this may be review, and it's not specific to AWS, but it's just general in a very elastic cloud-based environment. So what I'm going to talk about are concepts that you may have heard of before or used before, and then provide some AWS specifics around them. So on the left-hand side, you see this curve, capacity and demand. Ideally, when we scale our application and our resources in the cloud, we want our capacity to meet demand. So we don't want to pay for extra resources that are sitting there idle. So ideally, we actually try to get as close to that, get those two lines as close together as we can. It's not always technically or realistic to do so, but we try to. And we do that by scaling either vertically or horizontally. So think about an application, say our simple application before where we had, maybe it was a web server and a database sitting beneath it. Our application becomes more successful, more people are using it, and we need to grow it so that it can accommodate more traffic. We can do that first by scaling vertically. What I mean by that is taking that box that this application is sitting on and adding more CPU horsepower, adding more cores, maybe adding more memory, adding more disk space so that that particular instance or VM can take on more work. The issue with this approach, and it works very well, add a bigger box. The issue with it is eventually you reach a ceiling where you can't go any further. What do you do when you've added the biggest box or in a virtualized environment? What do you do when your virtual instance actually matches what's available on the hardware underneath it? Where do you go from there? That's where we start talking about horizontal scalability. And for horizontal scalability is very simply take what you have and replicate it. And so in an environment, a typical use case would be, okay, now we need to have a load balancer in place. We're going to put 2 web servers underneath it, and we're going to distribute traffic across that load balancer to those 2 web servers. This allows us then to sort of take the next step where we can do this fairly automatically. If we have a fairly stateless, and I'll talk about this in just a second, if we have a fairly stateless service, maybe it's a web server that can very easily be put into production and start taking on load, we can start doing this automatically. When we notice through the use of metrics and monitoring that our customer demand is growing, we can automatically add capacity. And when we talk about stateless operation, these instances that we're adding and removing dynamically, ideally they need to be fairly stateless. And a good example of that is if we talk about a web server, for example, that's using a database underneath it. As users are logging in and logging out of that web server, perhaps the session information about that user's login is stored locally on that web server. So imagine a case where, actually I'll skip forward and, yeah. So imagine a case where you've got multiple applications running beneath a load balancer. A user logs in, their session information is stored on that box that they actually logged in on. If we're in a dynamically scaling environment where instances are added and removed at any point in time, the instance that, or the instance that user logged into might go away. So what happens to that user session at that point? It disappears, and the user may have to re-log in, or they may lose some valuable work. So ideally, we want those web servers or applications to be stateless, and we put that state somewhere else. So in this case, if it was a web server, we've got session state, we might want to put it out onto a distributed memcache server or some other cache. We also find in this space that instances that scale up and down dynamically tend to be fairly self-aware, and by that I mean they are able to bootstrap themselves. So you bring a new instance up, it knows who it is, what its job is, where it's supposed to go to get the latest source code, where it goes to get configuration. You know, in this case on AWS, that might be in S3 or in DynamoDB, but it allows itself to it adds itself perhaps to the ELB when it's ready to start taking traffic. So everything tends to start happening dynamically now. It doesn't require any human intervention. And as I showed here, this is essentially what it starts to look like. Now you have, instead of a single application on a single box, the next evolutionary step is we've spread our application out. Perhaps we've separated out the database to its own EC2 instance. We now have multiple applications and a load balancer. In AWS, for those of you who haven't used it before, the load balancer, that rectangular box at the top, that's represented in AWS by an elastic load balancer, an ELB. The applications themselves run on EC2 instances, and the database can run on an EC2 instance, Elastic Cloud Compute, or might run in one of their managed services. How do you scale a database, though? So you can scale the application horizontally or vertically. How do you scale a database? So very similarly with databases, we can evolve them by scaling them vertically. Again, adding additional CPU, adding additional memory so that more in-memory operations can occur, adding more disk space so that we can grow the size of the database. But again, even like was the case with applications, you can only scale vertically so far. At some point, you have to do something else. So we start talking about horizontal scaling again with databases. And I'll talk just sort of in general terms here. There are other options available. Horizontal scaling, when we think about databases, and we were talking about application scaling horizontally and the idea of state and not wanting to have state on those instances. The database is state. That's its definition. It is the state of the system. And so we can't just scale it horizontally simply by replicating that box. We have to do something different. We have to look at very specific use cases. So one option when we're scaling databases horizontally, for example, is to look at the different use cases. So some databases, some applications may be very read-heavy. And in the case of a read-heavy application, we have the opportunity to introduce read replicas into the system. So we're scaling horizontally by replicating data out to another database, asynchronously in this case, and then redirecting read operations to that read replica. And so unlike horizontal scaling of an app tier or a web tier, this actually requires some knowledge of the application. Now it needs to know, oh, I can send read requests to this other database. This introduces some other complications into the system too. Now, because we're replicating asynchronously, we need to be aware of potential data consistency issues. So you don't have true read after write semantics. Your application needs to be able to take advantage of that. Some applications can't. You may actually need to be able to read from a database immediately after writing. But it does allow you to horizontally scale this out and add more capacity to your database. The block that I put in there is caching. This is somewhat a form of horizontal scaling for databases in that we can actually cache information off database. And it introduces the same caveats where now we have TTLs associated with this data. The application needs to know that, hey, this data may not be the most current. And if I do need the most current, I need to go to the master database. The other options here, so if in the case where you're not necessarily read heavy, but you're write heavy, there are other options that we can take when scaling our database horizontally. They're both sort of forms of partitioning, but we can shard or partition our database. So think about a very simple e-commerce application, for example, that has users, it has products, and it has orders. When we think about sharding our database, say, for example, we've noticed an increased load, our database is starting to, performance of the database is starting to degrade. When we think about sharding our database, we actually think about partitioning the database, essentially by rows. We want to put all of the user information for users A through H in one database, I through S in another, and so on and so forth, and essentially spread that load across multiple databases. Again, this requires knowledge of the application now to know that, okay, when I want to do a query or I want to write information about a particular user, I need to go to this shard. I need to manage that. Now, this sort of assumes that you've got a normal distribution of access to all of these users. If you have hotspots in your users, more active users, or in any one particular database, you have to look at it from a different perspective. Another approach to horizontal scaling in databases is partitioning. And in this case, very similarly, instead of partitioning along users as we did in sharding, we actually take users, products, and orders, completely separate them out and put them in their own database. That way, you can scale each one of those independent of the other now. So if your user's database is fairly static and doesn't change much, it could require a smaller database instance to run. Your products, again, that may be fairly static, so you can scale it different. Your orders may be fairly dynamic. It may be more read heavy. So you can actually scale, you can shard and partition each one of these independent of the other. It also lends itself then to other, we'll talk a little bit more about this a little later on. It lends itself well to service-oriented architectures or microarchitectures, which we'll talk about just briefly coming up, actually right now. So sort of switching gears, we talked about making applications and databases more scalable. The second thing that we see about architectures that make them successful are resilient architectures. Let me talk about that just for a few minutes. What does it mean? What does it mean to be highly available in the cloud? What does it mean to be available just in general? Well, the first thing that it means is being resilient. That means that when something happens, we don't just fall over. That we can gracefully degrade our operation and recover when things get better. You've set your application up, you've configured it so that it scales automatically, you've scaled out your database such that it can accommodate the heaviest of loads, you're prepared for the Christmas season or Black Friday coming up, everything is running very smoothly. What happens when something goes wrong? What happens when a service that you're dependent on fails? How does your application present itself to your end user, whether that end user be an actual person on the end of at the other end of a web page or another system that's simply calling APIs? We want to make sure that we're graceful, we're resilient, and we're also somewhat fungible. Not in the sense that every component within our system can be replaced by every other component, but simply that most of the components within our architecture aren't really special, that they're not one-offs, that they can be replaced when needed. When we're architecting for failure in the cloud and thinking about those downstream services that might fail, we need to think about other architectural best practices. And some of you may recognize these. These aren't particular to cloud-based best practices for architecture. These are similar to what you might see if you were a software developer. Decoupling, asynchronous operations, single points of failure, metrics, and monitoring. We apply the same sort of techniques in the cloud. A good example of decoupling services and asynchronous operations in the cloud to make our applications more resilient is, say, for example, you have a web server that does image processing, and one of the operations it does is creating image thumbnails, for example. In a synchronous coupled environment, one server makes a request to another server, the other server would do whatever operation to that image, make a thumbnail of it, and then send a response back, and the other server would wait. Ideally, what we want to do is decouple these two, and we can do that by placing, for example, a queue in between them. So now instead of the upstream service making a direct call to the downstream service, we place a queue in place. The upstream service serializes information about that job, places it into the queue, and then goes off and monitors the progress of that operation somewhere else. A downstream service, the service that's actually doing the image processing, monitors that queue as well. It sees a job on there, it takes it off, it does whatever operation it has to, and then it updates a status somewhere in a centralized database. Now, the nice thing about this is number one, it decouples the two. So now, talking about scalability, we can actually vary those independent of one another. So now we've got two services. I can scale the upstream service independent of the downstream service. It also isolates the two. So if the downstream service, if there's some sort of failure in the downstream service is not able to actually do processing, the upstream service can still place items in the queue. It's completely unaware of that. Yes, the queue depth keeps growing and perhaps the customer experience degrades, but it doesn't completely tip over. And so that is very appealing from that perspective. It allows us to vary those two. And then we can actually do some interesting things with scalability in this case. Now we can monitor the depth of the queue, and we can scale our downstream services to add or remove instances to do processing based on the depth of that queue. Single points of failure, as I mentioned before, one of the things that we want to try to do, especially in the case of creating a resilient application, is avoid single points of failure. So, I mean, obviously, if you have a single database in your system, that's a single point of failure. If you have a single web server in your system, that's a single point of failure. We want to identify all those and come up with strategies. Perhaps we can't completely reduce that single point of failure, but we can minimize the amount of downtime we take for it. You're always going to come across applications that you simply can't scale. A commercial off-the-shelf application, you don't have access to the source code. Perhaps it's a licensing issue where you can only ever have one of them running at a time. You can't really scale those out horizontally, so you want to put practices in place that allow you to automatically restart or reprovision that instance in case of failure. And we do that, with auto-scaling groups in AWS and load balancers. The last point on this is monitoring and metrics. The key to any successful application, highly scalable and available application in AWS or any other cloud environment, is really metrics and monitoring. They're the underpinning for any type of automation that you want to do. So for scaling, adding, or removing instances to your applications, you're going to be using metrics. It's also the key for a DevOps environment. We need to be able to go in and figure out where things are going wrong, and we use lots of, metrics and monitoring to accomplish that. I spoke briefly just a few minutes ago about microservices. This is sort of, if you take decoupling and asynchronous operation and scalability and availability, sort of, at least in my mind, to the obvious logical conclusion, you end up with some form of microservices. And for those of you who aren't familiar with microservices, it's really taking your application and breaking it down into its component parts. So in our example before, where we had products and users and orders, we actually create microservices. We might create microservices around each one of those. So there would be a products database and then a products application, a web application, or business logic associated around that. And so now you break up your application. I don't have a good diagram of this, but it really ends up being maybe a hub and spoke type of model or a complete mesh model where you have all of these applications talking to one another. The downside of this is, it's fun from an engineering perspective. I love being able to do this, but it was kind of funny when I was putting this slide together. I mean, I created this slide deck. You can see the date back in October. This tweet actually came across my Twitter feed. So the downside of doing all this, when you had this one big monolithic application and something went wrong, you knew where to go look. It was somewhere in there. Yeah, maybe it was a complete mess of spaghetti code, but at least you knew it was there. Now with microservices, you can go to the extreme where you get paged at 2 o'clock in the morning. It's now a murder mystery. It's not simply go in and figure out what's going on in this one application. You have to do some forensic analysis. So we can take it to the extreme. I also wanted to mention, how many of you have heard of the pets versus cattle paradigm? Okay, so I used to work in a company about 10 years ago. It was a small security company in Portland. We had our own data center in the back office. We had racks, we had monitors, keyboards, the whole 9 yards. We also had, for every computer that we had back there, it had a little sticker on it with a name. I don't know if it was a color or a number, what have you, but we referred to them by name. And when something went wrong with one of them, we nurtured it back to health. This was an actual physical box. If a power supply went out, we got it a new power supply, we repaired it, we stood by it, we brought it back to health, we put it back into production. That's sort of the pet model. And in today's environment, in a cloud environment, we don't want to treat these virtual appliances as pets. We don't want to nurture them. We actually want to treat them more like cattle. And where cattle are replaceable. So if if one of them gets sick, you don't nurture it back to health. You just take it behind the barn and take care of it. And replace it with something else. So that's really the point. You really don't care about it. You actually bring another one in its place and do something else with the one that's there. This was actually, I think, a slide I took from a CERN presentation. In terms of availability, we're talking mainly about availability and resiliency of applications in the cloud. With databases, it's somewhat similar. We can do things with databases like replication. So if we want our database to be highly available, instead of having a single node, we now have to have multiples. So a master-slave environment or a master-master environment where we can replicate data. So in the case of failover, we can switch the primary to another one. In the case of Amazon's relational database service, their managed database service, they actually provide that as a feature of their service. You can launch multiple database instances and have automated failover in case the primary ever fails. We can also introduce caching into databases to improve availability. As we saw it sort of in the read-heavy database case, we can put a cache in place so that if something does happen to the database, we can still go to the cache, maybe in a degraded read-only type of mode, but it's still there and still available. I want to leave you, this is really the last slide. I want to leave you, actually there's one more behind this, but this is Werner Vogels from AWS, who's the CTO of Amazon, and he had this saying that everything fails all the time. And in the case of AWS, in the case of any cloud infrastructure, in the case of dedicated infrastructure, everything is going to fail at some point, whether it's your application, whether it's the actual hardware that your application is running on. It could be a rack in an actual data center. You need to be prepared for that. And the comment above, lessons from the cloud failure, it's not Amazon, it's you, that's really to the point that Amazon AWS is going to provide you with all of this infrastructure. You need to understand and be aware that at some point this infrastructure could fail, individual components of it, data centers, regions. You need to come up with a strategy to mitigate those failures if you need to. It all depends on the level of availability that you want. I'm going to skip through that one. Actually, that was the last thing I want to leave you with is this slide right here, which is adaptable. The key to success on AWS or any other cloud is to be adaptable, to make sure that your application is adaptable to the environment around it, that it's adaptable to the changes, that you're able to evolve it using the latest and greatest services that are available on AWS. And really, that's the whole point of me being here. That's what I do on a day-to-day basis. I work with AWS customers, with Rackspace customers who are AWS users, and I help them map their business needs, their application needs to Amazon. And it's not something that we do, it's not a fire and forget type of event when we start managing AWS resources. It's something we do on an ongoing basis. So as I work with AWS customers, I look at their architecture, I learn their architecture, become familiar with it, and then on an ongoing basis we review that and make sure they're continuing to adhere to best practices and provide additional guidance to them if they need it. Again, if you want any more information about this, you can go to rackspace.com/AWS. I'm going to be here for the rest of the day. If you want to go deep, if you want to get technical, we can do that. If you just want to talk about the offering itself, if you want to talk about making scalable and available applications on AWS, I'm available for that. We also have a booth set up out here where we have several of us who would be more than happy to talk to you about this. I appreciate you coming today. I'm glad to have been able to come here and talk to you about this. I hope you have a great day, and I hope you've had a great conference here. Thank you very much.
Thank you, Jerry. Coming up next, our general session, our final general session resumes at 4:40 p.m. in approximately 6 minutes. So take a quick break if you like, but come back for